think the first question is directed to Pierre. I remember in Rajot, if I remember correct, with the extract fan through the long duct. Has there been any problems with the fire regulations? As this is like a huge chimney, did you experience any problems there?
We did not, because it was not under the law, but we had explored that in the sense that the shafts are often like this open anyway. So if you add a fan and that the fan will stop instantaneously in case of fire, then it would be like the shaft is normally, because the shafts are generally open to the sky in India. So I mean, I'm not saying there is no problem, because obviously if there was a fire, but generally you have this exhaust. When we draw through this exhaust, it is nothing else that the exhaust which are there anyway, that they have without draft, but they have the same kind of thing. So fire can propagate in this kind of internal courtyard, and it's something which is, you have to remember that there is no technical, let's say, there is nothing technical else than the fan and this balanced exhaust, which are just static. So there is no, I would say, compared to other building in India of the same kind, it's not an issue. But I agree, it could be an issue. It could be an issue, but it's not considered as. But and in India, I think this would be accepted as it is. Maybe in some state, because India is a federal state, so in terms of fire, there might be some difference in some of the state. But in this state, it was not an issue when we were doing the trial.
Okay, thanks. Yeah, we will just continue with Pierre. I think. So has there been any comparison between the cooling energy saved or the heat extracted and the energy used by the extract fans? So
actually, we were not able to go to this level because we had some time limitation. The people were entering into the building, and actually we could not do it when it was really hot, so we could not check. I mean, we know by simulation that the extract fan, and if you have 1 watt per square meter, I think if you do a comparison with a conventional cooling, you will be much better for the night if you compare, definitely. But we are going to publish something soon on this, but but we can't. I mean, the main idea here was to demonstrate that with 1 watt per square meter, you can bring more than 10 air change at night with a very low energy ventilative cooling, and it's balanced between the flat. That was the main idea. That say you can have just a centralized for each shaft 1 fan and draw approximately the same airflow through all the flats. And really, so again, it comes back to the number. There is a study of Per Heiselberg who shown this, that going from 2 air change to 12 air change is a factor almost 5 in the power you remove from the walls.
Yeah, the last, like the third question on this is concerning the. I think you managed that it's balanced. So in the height of the flats, usually there's a huge difference on the flow rates. If you scroll up, Maria, it's the third question.
Well, I did not get.
So concerning the very tall buildings, if you have a flat on the top or one in the bottom, there's usually a huge difference in under pressure.
No, because we are extracting the air. We keep the same negative pressure in the shaft. So I'm not talking of a 40-story building, of course, then it would be different. But here we were on 8 stories. I think if you would do it on let's say a 40-story building, you would have to make few extracted different floors. I think you may because I agree that if you go on higher level, then you would start having a different pressure. But still, we didn't see this difference of pressure. We had a really constant static pressure from bottom to top in the shaft. And that's how it is giving a good, and that's why we had to put something more significant than if you have just the wind, because it's not generally few Pascal. Here we have really 30 Pascal. I think is a good optimal negative pressure to have sufficient, let's say, pressure loss to balance the flow. Because if you reduce it, then you would have this kind of big difference due to small difference in pressure. But in this case, with 30 Pascal across the opening, then it does make that the balancing is really good.
Okay, thanks. I think there's another question for you.
Yeah.
Yeah, concerning the last example, is it the indoor temperature below 35% occurred, even at days with only 30% temperature outside? Is this because of the solar gain?
Which one? Which one of the?
I think the last example concerning the external shadings.
Oh, the last example. Actually, it was the measurement we have done here. We have shown a dynamic. So there has been quite quick temperature rise, and of course there are some so to say unsteady, let's say, behavior. But we have seen on the longer duration that the 3.5 degree occur on any clear day. We are in this range. That means between external shading or no external shading, we have approximately 3.5 degree. And we did the same test, but we did not present it here with air conditioning. We are getting 32% gain on the total cooling load with this external shading.
Okay, thank you, Pierre. I think we start from the beginning now. So questions for Ronan. One question for Ronan. I hope you're still here with us. We understand you are collecting policy actions. You have optimism to be able to somehow even evaluate the success rate of these policy actions?
That's a good question. Within the current four-year annex, I'm not sure that the policy actions will have reached the point where we can evaluate the success rates. This seems like an opportunity to establish some follow-on work. I'll bring this question back to the working group, and we'll think about how to set up these actions so that we can gauge their success.
For that. Let's continue with the high-end Gerhard. So it's concerning the case study report at the end. Will the real address and the specific information on the buildings will be available so that people can maybe visit and see the buildings? Or is there any anonymization of the information to be done? I hope you can still hear me, Gerhard, or the high.
Yeah, so I would propose that we will give the information of the real address. So I think most of the buildings and buildings owner will have a real address. I'm not sure if anyone doesn't like it, so, but I think most of the project will have a real address in this case study report.
Okay, that's good news. And for Margot, I think there were some questions for Margot. Yes, great questions. So concerning the application of surface cooling, which recommendation would you give in terms of humidity of outside climate, so dew point temperature, for example, as a limiting factor of surface cooling? Is there a general answer to this question?
I don't know if I understand it right, but I think that in the residential cases that we studied, it was not really a limiting factor. And the only recommendation that I have was what I mentioned, that it's not needed to do an on-off control, but you can still keep on cooling, but just with a higher supply temperature.
So that as we saw that it's not switching back and forth all the time.
Mm-hmm.
Okay, second question number 2. The regeneration of the boreholes. I think the question is, did we get this right? That there's a problem in future climate scenarios?
Yes, that's about the paper that I refer to. Maybe Hilde will know more about it. I think it's not especially the regeneration, but the fact that the ground itself will also warm up because of climate change. So I showed in some of the graphs that we had 19 degrees during a whole summer. I think that we will in the future not start at 19 degrees, but it will be higher.
Maybe here I may just add a little thing. In India, the boreholes are generally already at 24, 25 at least. So the
Okay.
ground temperature is higher really by something like almost 10 degrees. So it will depend on the countries and the geographic location that you can use them or not. In terms of today already, there is a problem with people trying to cool even the condenser of the machines with that in India. So I think really the situation is different depending on the geographic location and the climate locally.
Mm-hmm.
Yeah, as we switch from heating to like from a heating dominated climate to a cooling dominated climate, I think there's a huge impact on these boreholes, which we have to take in mind. So and the last question, what is the problem of high humidity byproduct of the evaporative cooling?
I think there he refers to the high humidity in the first dwelling, but there we didn't have evaporative cooling, but we had the cooling coil. And it was only in the second year that the cooling coil was installed, but we had already high humidity in the first year. So I don't think there is really a relation with the evaporative cooling.
May I join in, Margot, with a question?
Mm-hmm.
This is Peter speaking. Didn't I get it right? The evaporative cooling was an indirect evaporative cooling. So
Yes,
the effect of humidification did not directly affect the inlet air, but the cooling of the air could make the relative humidity at least higher.
Yes, that's right. Yeah.
Okay, thank you.